Very good morning, students. In this session, I'm going to discuss about two different categories of operating systems, namely multi-programming operating system and time-sharing operating system. Students, in our previous lecture, I discussed about the different roles of an operating system. The first role is an operating system acts as a government. A government will not do any task on its own. Instead of that one, a government creates an environment for other departments to carry out their task easily. So in an operating system also does the same task. An operating system itself will not do all the work. It creates an environment for others to do their work easily. The second role of an operating system is an operating system acts as a control program. It protects the computer system against any errors in the user program. If any error is there in the user programming, only that program is affected. But that program will not affect the functioning of a computer system. So that is the main role of an operating system. So when any error is there in the user programming, the operating system prevent that program from affecting the computer system. And we also discussed about how the operating system has evolved from early system to batch system. In early systems, a large computer executed directly from a console. Here, if the user wants any program to be executed, means he has to write the program using either a set of cards, or he can mount, or he can copy the program in a tape drive and pass either the tape drive or a set of cards to the operator along with the data and some control program, that some control instruction that describe how the program should work. Then the operator receives these things, mount a suitable tape drive containing the user program, and gives a control to the operating processor to start executing the user program. After the program execution is over, if there are no errors, if after successful execution, the output is either copied into a tape drive or the output is printed directly on the line printer, and that was given as an output to the user. Or in case of any errors in the user programming, in that case, output will not be printed on the paper. Instead of that one, the operator take out the content of the memory and give the content to the user to check whether where he is going wrong. So in this situation, what happens is the user cannot interact with the system when the program is executing. During execution of the program, he cannot interact with the system. In addition to this, early system suffer from one more drawback. Here, lot of setup is required. Whenever the user submit the program along with the data and some control information to the operator first has to mount a tape drive containing user program. Then he has to mount a tape drive containing a suitable compiler. After the execution is over, the result is mounted on another tape, and once the execution is completed, the tape drive has to be dismounted. So this involves lot of setup time. So in the case of early system, what happens is the setup time is more than the execution time. So in most of the times, we are keeping the CPU idle, because during this mounting of tape and dismounting of tape, CPU is not functioning. So we are keeping the CPU idle. So we are not utilizing it to the best possible way. To avoid that one, instead of sending the jobs one by one to the operator, what in the batch system, what we are doing is the set of jobs are given to the operator. Operator sorts them based on their similarity. All the similar jobs are grouped together and made it as a batch. Then assume that you have some set of some 5-10 program, out of that 5 are C program and 5 are Pascal program. Then what the operator will do is he will group the 5 C program as one batch and submit to the computer. After execution, the output of the 5 program was given to the user. Then he takes the second set of job and load it to the computer, and after executing, the output is once again passed on to the user. So instead of loading the program one by one and executing, here the programs are loaded in batch. So in the previous case, setup time was involved with every job. Here setup is required only for one batch of programs at a time. So the setup time is drastically reduced in the case of batch operating system. But the batch operating system also suffer from a drawback. Here also the user cannot interact with the system while the program is executing. But here also setup time is involved. And to avoid these two drawbacks, they come out with two different types of operating system, namely multi-programming operating system and time-sharing operating system. The main objective of this session to discuss how a multi-programming and time-sharing operating system works, what are the advantages and disadvantages of each of these two types. After attending the session, you will understand how a multi-programming system and time-sharing system works, what is the difference among these two types, what are the merits and demerits of each of these two. In a multi-programming system, what happens is, here instead of one program, we are keeping set of program in the main memory. Assume that we have some 25 program to be executed. But one thing you should remember is, a computer main memory is a very valuable resource, and the amount of main memory is much less than the amount of secondary memory in any computer. Even though you have 25 jobs to be executed, all the 25 jobs cannot be brought to the main memory at a time. So what they do is, depending on your memory capacity, first some 5 jobs from the secondary memory is brought to the main memory. So because our main memory is not enough to keep all the 25 jobs. So depending on the main memory capacity, assume that our main memory is capable of loading only or capable of storing only 5 programs. In that case, out of 25 jobs, we bring first 5 jobs from the secondary memory to the primary memory. Now your main memory contains 5 jobs. Name it as J1, J2, J3, J4 and J5. Now the CPU start executing the job 1 first. Keep on executing. Suppose in between job 1 has some input-output operation. For doing input-output operation, CPU is not required or processor is not required. In that case, processor leaves the job 1 and automatically moves to job 2. Keep on executing job 2. Suppose job 2 also has some input-output operation. Again, the CPU will not wait till the input-output operation is completed. It will leave the job and go to the next job called J3. Suppose J3 has no input-output operation, means that job is completely executed. Then go to job 4. Suppose job 4 has IO operation. Leave that job, move to job 5. After executing job 5, it will come back and check whether by this time job 1, job 2 and job 4 have completed their input-output operation. If it is so, then again start executing job 1 from the point where it left earlier. After executing job 1, goes to job 2, successfully execute the job 2 also, because job 3 was previously executed. Then move to job 4, because job 4 also has some IO operation. Then after executing job 4, your CPU will stop. So in the case of multi-programming, instead of keeping one program in main memory, we are keeping several programs in the memory. The main concept of multi-programming is, your CPU will be busy as long as some job is there in your main memory. Suppose your main memory is capable of storing 10 programs, then out of available jobs in second memory, you can bring 10 jobs into the main memory simultaneously. In that case, your CPU will be busy as long as all the 10 jobs have been successfully or completely executed. So the main intention of designing a multi-programming system is to keep the CPU as busy as possible. We are not leaving the CPU idle at any time as long as some job is there in your primary memory. Let us take this simple example where your main memory can accommodate only 4 jobs. Now what happens is, here also CPU start executing job 1. If there are no IO operation, then it goes to job 2 after executing job 1. And job 2 also no IO operation, means only after executing both job 1 and job 2 it go to job 3. Job 3 has some IO operation, means leaves the job there only, goes to job 4. Job 4 also has IO operation, means leave it, then come back. because already job 1 and job 2 are executed completely. Then it start executing job 3 if it has completed its IO operation. So here what happens is your CPU will be busy as long as all the 4 jobs are completely executed. What are the advantages and disadvantages? We'll see here. In the case of multi-programming system, since many programs or many jobs are there in the main memory, you are keeping the busy most of the time. So your CPU can be busy all the time. It gives you higher throughput. That means you can do more work in a given amount of time. Not only you are keeping the CPU busy, your input-output device is also busy. Because if more than one job had some IO operation, means your IO device is also busy because it has to finish the IO operation for 2-3 jobs. So in the case of multi-programming, our main intention is to not to waste any resources, whether it is CPU or whether it is an IO device. We are keeping both of them as busy as possible to get maximum out of it. The main problem with multi-programming system is the waiting time is not uniform. The meaning is, you consider these 4 jobs. Assume that job 1 has requires some 100 seconds of CPU time to completely execute. Job 2 needs some 200 seconds. Job 3 requires some 200 seconds. And job 4 needs some 20 seconds of time. Now what happens is, assume that job 1, job 2, job 3, job 4, all the 4 jobs are there in the main memory. The CPU time requirement is, for job 1 it is 100 second or 100 millisecond, job 2 200, job 3 200, and job 4 20 seconds. Now what happens is, assume that all the 4 jobs are IO operation free. That means none of the job has some input-output operation. In that case, what happens is, job 1, the CPU start executing immediately. So that job need not wait at all. So the waiting time for job 1 is 0. But CPU start executing job 1 only after completing job 1. Suppose the requirement for job 1 is 100 seconds, means then the waiting time for job 2 will be 100 seconds. Job 3 will be executed only after completing job 1 and job 2. So job 1 needs 100 seconds, job 2 needs 200 seconds, means job 3's waiting time will be 300 seconds. And for job 4, it has to wait till all the previous jobs are completely executed. So its waiting time will be 500 seconds. You look at the case of job 4. Its CPU requirement is only 20 seconds. For getting the CPU for 20 seconds, it has to wait for 500 seconds. So here what happens is, job 1 waiting time is 0. The waiting time job 2 is more than job 1. Waiting time of job 3 is more than job 1, job 2. And for the last job, the waiting time is too much. That's the reason in the case of multi-programming operating system, the waiting time is not common. It varies from job to job. And in addition to that one, which set of job should be brought from secondary memory to secondary memory? So whether it is first 4 job or first 10 job, or so even after bringing the 10 jobs into the main memory, which job should be executed first, whether it is a job 1 or job 2 or job 3. All these things require designing suitable job scheduling algorithm. Anyway, there is a separate chapter on CPU scheduling. At that time, I will explain what are all the available job scheduling algorithm and what are the merits and demerits of each of these job scheduling algorithms. So the second drawback of multi-programming is designing of sophisticated job scheduling algorithms. And here also, the user does not have any control over his program while it is being executed. Only after execution, he can take care of his program. But when the program is executing, in between, he cannot interact with the processor. The next improved version of the operating system is time sharing operating system. A time sharing operating system is an improved version of multi-programming. In the case of time sharing operating system also, instead of one job, we are bringing several jobs into the main memory simultaneously. But the idea behind the design of a time sharing operating system is to make the waiting time as uniform as possible. For that one, what it will do is, after you bring some set of jobs into the prime memory, assume that we have brought first 4 jobs into the primary memory, namely job 1, job 2, job 3, job 4. and the requirement is 100 second, 200 second, 200 second, and 20 second, as I explained in the multi-program. In the case of time sharing, in the case of multi-programming system, what happens is job 2 is executed only after executing job 1. Job 3 is executed only after executing job 1 and job 2. But it is not the case in the case of time sharing. Here, what the operating system will do is it fix some limit, some time limit called time quantum. Then the CPU execute, assume that in this example, fix the time limit as 20 seconds. What the operating system will do is it goes to the first program executing. The requirement for job 1 is 100 seconds, but the operating system has fixed the time quantum as only 20 seconds. In that case, what it will, the processor will do it will execute the job 1 only for 20 seconds. Immediately it go to the next job. Next job is also executed for only 20 seconds. Go to the next job. Execute that job also for 20 seconds. Go to the last job. Last job requirement is just 20 seconds. Completely executed. Now, 1 second. So one rotation is over. In one rotation, every job that is there in your primary memory will get the CPU for one time quantum duration. Next, the CPU goes to the second rotation. Second rotation, execute the first job again for another 20 seconds. Go to job 2, execute for 20 seconds. Go to third job for executed. Then go to third round. So in every rotation, here what happens? Every job will get the CPU at least for one time quantum duration. But the time quantum duration, how much should be set is left to the operating system. But here what happens is one job need not wait till the complete execution of the previous job. Only every job will get the CPU share of one time quantum in every cycle. So that is the main advantage of time sharing system. So here what happens is none of the job has to wait for too long, and none of the job will get the CPU for a long duration also. So this is also one way of sharing your computer processor simultaneously by many users. But another advantage of time sharing operating system is it is mainly suitable for interactive systems. But in the case of time sharing system, what happens is your process, generally time sharing systems are used when your processor is very, very fast. The CPU move from one processor to another processor in such a fast rate that every user will think that CPU is always executing his program. Because go from first job to second job to third job very, very fast, and immediately come back to first job only. So the user one or the job one thinks that one CPU is always executing his program. But the reality is not like that. Reality, CPU is executing all the jobs for one time quantum duration in a cycle. But for the user, he will get the impression that the CPU is always executing only his program. That is the beauty of time sharing operating system. Even though the CPU shared among several users, none of the user gets the impression that the CPU is shared by other counterpart also. He thinks that one CPU is always executing his program. Time sharing operating system also has certain advantages as well as certain disadvantages. Here, waiting time is as uniform as possible when compared to multi-programming, where the uniform waiting time is not there. Here you have uniform waiting time. Here also, CPU is utilized in a best possible manner, so better utilization of the CPU. And mainly, the main advantage of time sharing operating system is it's suitable for interactive applications like your gaming applications. But it's very complex when compared to multi-programming operating system. Here also, since many users are sharing the computer resource simultaneously, you should have a better memory management technique, as well as security also is a major issue in the case of time sharing operating system. Actually, security is an issue in the case of multi-programming also. So we require sophisticated memory management technique and sophisticated security technique for implementing time sharing operating system. So these are the two drawbacks of time sharing operating system when compared to multi-programming. But definitely time sharing is much better than a multi-programming, because we are making a waiting time for all the job as uniform as possible. So students, in this today's session, we discussed about what do you mean by multi-programming, how multi-programming is done in the case of operating system, what are the merits and demerits of multi-programming, where multi-programming is useful, in what way multi-programming is better than batch system, etc. We also discussed about another powerful operating system called time sharing, where the CPU or the processor is not only processor, even the memory also processor is shared among multiple users. What are the advantages and disadvantages of time sharing operating system when compared to multi-programming? So all these things we have discussed in today's session. So these types of operating system are very, very important. So definitely in your examination, one question definitely come from this section. The question could be explain multi-programmed operating system with its merits and demerits. Discuss the concept of time sharing operating system. How a multi-programming operating system or time sharing operating system is different from multi-programming, and multi-programming is different from time sharing system. And for 2 marks, they can give the question, time sharing operating system is better than multi-programming. You can justify. Because definitely, when compared to multi-programming, your waiting time is uniform in the case of time sharing system. So these are the some of the multiple choice question based on today's topic. In a time sharing system, unit of time that CPU allocated to each process in one turn is called as, we call it as time quantum. So correct answer is B. The main drawback of multi-programming system is poor utilization. No, because multi-program result in better CPU utilization, more setup time. Setup time is more in the case of batch system. No uniform waiting time. Yes, waiting time is not uniform in the case of multi-programming system. And no security. No, security definitely is taken care by the designers. So the correct answer is C. Higher CPU utilization can be achieved in batch processing, resident monitor, nothing but early system, multi-programming, offline processing. So far you have not discussed about anything about the offline processing. So that I'm going to discuss in the next session. So the correct answer is C. Identify the incorrect statement. Multi-programming allows more than one program in memory simultaneously. That's a correct statement. Time sharing is suitable for interactive application. That's also true. Time sharing has uniform waiting time. That's also true. Multi-programming has uniform waiting time. No, multi-programming waiting time is not uniform across all jobs. The correct answer is D. In multi-programming, CPU is switched over to next process when in only 2 situations. After completely executing that job, if there are no IO operation, or in between if the IO operation is involved, then also it will switch. So after time quantum is over, no. Time quantum concept comes only in the case of time sharing system. Randomly wrong. The currently executing process has IO operations true. The correct answer is C. So students, I'm going to wind up today's session. At this point, if you have any queries, feedback, you can call me over that number, you can mail me, or you can post your comment in the comment section of the Google class also. I'm expecting your valuable feedback even for previous sessions also, so that it will be useful for me to update. Thank you. Thank you, one and all.